Hello again. In this video, after a short review of on and off delay timers, we're going to do a simple project. Alright. This the ladder symbol of on delay timer. This one is its FBD symbol. And these are off delay timer in ladder and FBD language. We can notice these timers with a small syntax TON and TOF. As you know, each timer need a data block to work correctly. Each timer has two outputs, but their sequence in ladder and FBD are different. If we need to store and use elapsed time, we must use an address with 32 bits such as MD4. MD4 refers to PLC memory, which include byte 4 to byte 7. For another timer, we can use byte 8 to byte 11 of PLC memory, with MD8 address. Now let's do a simple project with on and off delay timers. See this production line which has been designed in the factory I/O. Here we have four outputs, M1 to M4. M1 is an emitter in the factory I/O. This enter boxes to the plant. M2 and M3 are conveyors which move boxes, and M4 is a remover. Here is a question. To start this line, we must turn on equipment from M1 which is at the first of this plant, or from M4 which is the last equipment. Let me do a small test. As you see, if the first conveyor is started and the second ones can't be turned on with any reason, boxes are accumulated on the second conveyor. So usually equipment are started from the last ones to first in a line production. Also, when a line is going to be stopped, equipment are turned off from the first of line, to its last equipment. Otherwise it's maybe some boxes remain on the conveyors. So try to write a program to turn on these four outputs from M4 to M1. And turn off them from M1 to M4. This can be our PLC wiring for this project. There are two start and stop push buttons. And we have four outputs which are connected to PLC. As you know, for devices such as conveyors which a PLC can't turn them on, it needs to relays and power circuits too. But here, we only want to learn to use and program PLC. So to test our programs, we don't need this part. Let's start to write a program in ladder language. As you know, we need this block to use factory I/O beside our virtual PLC. Now let insert 4 assignment respectively for outputs. By default, in every network, comments of the first output appears here. Now, let me save start and stop request in a bit memory like previous videos. Okay, maybe you say this program is wrong, because the last network must be used in the first network, according previous videos. Pay attention, CPU runs network 1, 2, 3 to network 6 and again repeat that, so although network 6 is placed at the end of this program, but actually it's placed at the first of next repeat. Now let me place this start-stop bit memory at the first of each output. Let's see the plant. When the start push buttons is pressed, the emitter, which is placed at the first of this plant, must be turned on after all devices. If I consider 5 seconds for each output, the emitter must be turned on after 15 seconds. The first conveyor must be started after second conveyor and remover. So when the start push button is pressed, this output must be turned on after about 10 seconds. As the same way, I need 5 seconds delay to start the second conveyor. The last output, remover, it must start immediately after the start push button is pressed, so for this output we don't need delay. But when the stop push button is pressed, this output must be turned off after all devices. So here I insert an off delay timer with 15 seconds. With the same reasons, I insert two off delay timers with 10 and 5 seconds. For the first output, emitter, it must stop immediately after the stop push buttons is pressed, so for this output, I don't need off delay timer. Another point in programming is consider some safety conditions. We want to start emitter when all devices are on. So I insert a normally contact of other outputs, before this output. With this logic, if remover or each of conveyor are stopped, the virtual power can't reach to emitter, and thus output will be off. With same reason, I insert two normally open contact of second conveyor and remover here. Here, I just insert a normally open contact of remover. This makes, if the remover is off, the second conveyor can be turned on. Alright, let me transfer this program to a virtual PLC. Now I connect this plant to my virtual PLC. Finally, based on this wiring, factory devices must be connected to PLC. Now let me test this program. Well, it seems here is a problem, my start push button doesn't work. Let's see its related contact in my programs. Alright, the SR flip-flop is resetting its output. Because the stop push button is normally closed. Here, I have to use a normally close contact, in reset input of SR flip-flop in my programs. So, let me to modify my programs. If I press start push button, second conveyor, first conveyor, and emitter, respectively will be on after 5, 10, and 15 seconds. Now let me press stop push button, it makes to stop the emitter immediately. Then, after 5, 10 and 15 seconds, first conveyor, second conveyor, and remover will be off. As you see, my program need a little modify in their timing. Because a box is still on the conveyor, after the line is stopped. Try to do this modification. Just change preset times. I hope you have understood. Start sequence in a line production. In the next video, we'll continue learning timer instructions. Thanks.